Hi, second grade. So we're going to go through your final capstone project where you're going to be building your own bridge, designing your own bridge, and then comparing it to the bridges that we have talked about, the Senator Bridge and the virtual bridge, which we talked about in your word problems earlier in this task. Sorry, had a brain moment. So first thing I want to do, I thought it'd be cool if before we dive into that learning about designing your bridge, let's learn about different kinds of bridges, okay? And then we'll talk about your topic and your project a little bit more, okay? So I'm gonna share my screen with you and share my sound. This is about a 6-minute video on the various types of bridges. So go ahead.
And how they work. Bridges always fascinate us. A bridge literally bridges or fills in the gap between two places and connects them in the most beautiful way. Don't you think so? There are many ingeniously constructed bridges in the world. In this video, we take you through the different types of bridges, and tell you about the civil engineering and aesthetics they involve. The suspension bridge is a type of bridge in which the deck, that is the roadbed, is hung with the help of suspension cables. The loads that it bears gets converted to tension in the cables and is transferred to the towers. This bridge can span long distances and resist earthquakes. It is preferably built across water bodies. It is a little complex and expensive to build. The Golden Gate Bridge in San Francisco, declared as one of the modern wonders of the world, is a suspension bridge. The cantilever bridge is built with cantilevers, which are structures that project along the x-axis in space, supported on one end only. Bridges intended to carry lesser traffic may use simple beams, while those meant to handle larger traffic make use of trusses or box girders. A cantilever bridge is easy to construct but difficult to maintain. The 1,800 feet Quebec Bridge of Canada holds the record of being the world's longest cantilever bridge. The Forth Bridge in Scotland is a railway bridge using the cantilever design and is one of the oldest known cantilever bridges.
The term drawbridge refers to a movable, bridge-like structure. Typically, it opens up to extend over the distance it is meant to span. A drawbridge has its inspiration from the castle bridge of the old times, which opened like a door, serving as an entrance to a castle. A vertical lift bridge is a drawbridge that moves vertically in a plane parallel to its deck. Bascule bridges are drawbridges that swing up and down to facilitate boat traffic.
The Tower Bridge in London is a well-known bascule bridge built across the River Thames.
A cable-stayed bridge is structured similar to a suspension bridge. The difference lies in the way cables are attached to support the load. In this case, the cables are attached to the towers, which bear the load. It has two variants, the harp and fan. In the harp design, cables are attached to multiple points of the tower in a parallel manner. In the fan variant, all the cables connect to the tower or pass over it. These bridges are much stiffer than suspension bridges, which is good, but they are more expensive to build than all the other types. An example of the cable-stayed bridge is the Millau Viaduct over the River Tarn in southern France. It is the tallest bridge in the world.
A beam bridge is derived from the typical wooden log bridge. Today, it is built using shallow steel beams, box girders and concrete. A horizontal beam supported at its ends is roughly how the structure of this bridge is. Highway overpasses, flyovers or walkways are often beam bridges. A beam bridge is the easiest to construct and the most inexpensive among all types of bridges. It has a limited span though. The longer a beam bridge, the weaker it is. Lake Pontchartrain Causeway is the world's longest continuous beam bridge over water. Arch bridges are arch-shaped and have supports at both ends. The entire weight is borne by these supports. The Romans were the first to discover the use of arches in bridge construction. Moon arch, pointed arch, deck arch and 2- or 3-storied arches are some variations of the arch bridge design. It is easy to construct and uneconomical at the same time. So today, other economical options are used instead of the arch bridge. The Mycenaean Archedica Bridge in Greece is the oldest existing arch-shaped bridge, and the Kashaiman Bridge in Chongqing, southwest China is the longest arch bridge in the world. It is 1741 meters in length.
A truss bridge is made up of truss, which is its main load-bearing structure. It is built by connecting straight elements with pin joints. The triangular units connected at the joints form the skeleton of a truss bridge. In the United States, truss bridges of the olden times used timber for compression and iron rods to bear tension. Truss bridges are very strong and efficient, but a little difficult to maintain. The deck truss railroad bridge that extends over the Erie Canal is one of the many famous truss bridges.
Thanks to the developments in engineering and architecture, the destinations which seemed unreachable could be bridged and reached.
Liked watching this? Then quickly give us a thumbs up and share it with all your friends. Don't forget to leave your comments below.
So now that we've talked a little bit about the different kinds of bridges, guys, and you learned the information. I know it wasn't like a fun video, but it gave us a lot of information about bridges. So now you can think about what kind of a bridge you want to design, okay? You can do a span bridge, you can do the arched bridge, or the suspension that has the wires that go up to hold them up. It doesn't matter. So go ahead and think about that, what kind of bridge you want to do, okay? And I want you to think about how big it's going to be and the name. Because on this paper right here in your folder, underneath the senator bridge and the virtual bridge in your table, you can write the name of your bridge and the length of your bridge in feet. The requirements for the length of your bridge in feet, it has to have a 3-digit number. So you have a number in the ones, a number in the tens, and the number in the hundreds. Pause this video and write down the name of your bridge and the length of your bridge. Make sure it's a 3-digit number, so it has 3 numbers in it. When you're done, click play and we'll continue. Okay, so now that you've got the name of your bridge and the length of your bridge, it's time to actually design the bridge, okay? So you're gonna go to the back of your project, and here is your workspace. Draw a picture of your bridge here, okay? Make sure you label it, okay? So label where the beams are there suspensions? Is there an arch, okay? Label the different parts. And what's nice is in your packet on a previous sheet, right here underneath your table, there is a picture with examples of the bridge being labeled, okay? So use that to help you too. Label your bridge, okay? So you know the different parts and how long it is. Then the next task is you are going to compare it to one of the other bridges. So the virtual bridge or the senator bridge. And you can write an addition equation, see how the total length is of both bridges combined. Remember, it's your bridge and one that was given to you in the packet. So always include your bridge. Or you can do maybe the difference. You can add or subtract. And here's an example here where it says, write the number sentence that represents a comparison you made with your bridge and one of the bridges from the chart, okay? So for example, the 852 plus 212 or 584 minus 212. So, I mean, pick the numbers that you want, your bridge and one of the other bridges, and add or subtract. Write that equation here. You can use the space up here. You should have a little bit of space up to show your work of how you add it or subtract it. And at the bottom, you're going to write and explain the comparison you made between the two bridges, okay? So think about that as, you could say, my bridge is longer than such and such bridge. And I know that because I did this, and this is how much longer it is. Parents, where you can come in to support your child in this is you can support your child by allowing them to give you the answer, and then you write and dictate the answer for them. That's perfectly fine in this, as long as your child can give you the explanation and you're just doing the writing for them, because we want to know the math behind it and their math thinking. And we can take out that demand of having to actually write it, and you can write it for them. Just make sure they explain it to you and you write down exactly what they say. Okay, so that is your final capstone for second grade, your math one, and you're done. I can't wait to see the bridges you design and your explanations behind it. So make sure you turn those in when you're done, friends, okay? I will see you later at our next lesson. You're doing an amazing job, and we are almost done. Bye.